Yeah, hello guys. So as for today, we will learn about frequency response related to pulse and zero. Response related to pulse and zeros. So as we learned before at LTI system, we is symmetry sorry uh frequency response for LTI system is symmetry. Therefore, pulse and zero will exist as conjugate pair. So that's mean whenever has a pole O0 at z equal to ej omega, it also will have at z equal to j omega. Poles and zero also have at z equal to j omega. Therefore, what this means that if there's at positive edge, they will also have at negative edge. So poles, if they has a positive edge, they also will have at negative edge. But you must remember that whenever poles or zeros are real, omega equal to 0 or pi, z will approach to r. Therefore, there has no pair. Alright. So for our group, we will focus about this graph. Its name is poles and zeros conjugate. So as for our group, we will teach you about frequency response for a pair of poles. So this is our job. Alright. So for poles, system function when only a pair of poles exists. Which mean by that, here's z is equal to 1 over with 1 over r e j theta z negative 1 multiply with 1 negative r e negative j theta z negative 1. We know, so we will rearrange it until it become this form: 1 re j theta z negative 1 plus a2, sorry, this is a1, 1 re j theta z negative 1, sorry, this is f negative theta. So this you need to use what we call that we need to you need to use some mathematical method. I don't remember what is it. Mathematical method. What is it? Mathematical method. I don't remember it. Later on in the class, I will explain how to get this in the class. Okay, alright. So how this is from this graph. This how to get from this to this. I will show you in class. This is theta. This is r. Remember, as the for frequency response, whenever there's a pulse at the positive side, there will pulse at negative side. Alright, so to the next page. So as we know, we will continue. As we know, Z is equal to E J omega. So hash Z, we will convert it to hash omega. So hash omega will equal to A1 over 1 minus R E J theta E negative J omega. Which mean by that Z Z negative 1 will convert to E negative J theta. Okay, alright, so we will change that for the whole of equation. So this will be RE negative J theta E negative J omega. So these two will we will simplify it more. A1 over 1 R E J theta minus omega plus A2 1 minus RE negative J theta plus omega. Alright. Okay. So this is the equations for poles. But from this equation, we will know that the magnitude of H omega maximum is when omega equal to omega equal to theta and omega equal to negative theta, where it will lead to E negative J omega theta and E negative J omega plus theta equal to 1. So therefore H omega will become infinity, because 1 minus 1 no, this is not valid, I'm sorry. So forget about this. So for both so therefore I will explain you about the range of R. The range of R is between 0 and 1. R cannot be less than 0, but cannot more than 1. So this is for stable and casual system. If it's more, it's not. It cannot be stable, or it cannot be casual. The system cannot be stable and casual if the R is more than 1 or less than 0. So within this range to hash, the magnitude of hash omega max increase as R increase. Okay. So from lecture note, you will see the difference of range of R. Page page 15. So on the slide you will see about the difference between range of R. At the left side is about range R that more than 1. The range of R is more than 1. So as you can see that the graph is slightly not accurate, not accurate, not stable and casual as the as the right side, which are more stable. Alright, so let's go to an example. So for today, I will explain you about example 3 on lecture note. It asks us to plot the magnitude of hash omega for hash n equal to 2 cos omega naught n u n. As we know, we need to change this to another form, as we learned before, that cos what is it, cos theta or cos something is equal to, wait, I need to refer the lecture note. So as we learn at the week 8, that cos omega equal to e j omega plus e negative j omega over 2. So this we need to transform into this. So the result will be, hash omega equal to, we need to make it in this form, infinity n equal to 0. It will be the e j omega naught n plus e negative j omega naught n un. We know this from the presentations. So when we simplify it, it will become in this form. When we simplify it, it will be at this form. Omega naught plus 1 over negative e j omega plus omega naught. So this equation is same as these equations. So what we need to do next is we need to find the value of h omega. But as we can the magnitude of h omega. So as we can see, if we let omega equal to omega naught or plus minus omega naught, hash omega will lead to infinity. Therefore, how to overcome this? Therefore, we need to use L'Hopital's rules. What is L'Hopital rules? So with this we need to remember from our last semester we learned during maths class. L'Hopital rules said that wait, I need to find my notes. Okay. L'Hopital rules said that as limit fx x approach to c, it will lead positive to positive and minus infinity, and as lim x approach c, gx will equal to plus minus infinity. Therefore, limit x approach to c, fx gx is equal to L. So we are using these rules to get the answer. And after we using this rule, this equation will become hash omega equal to this is what you call delta, whatever it is, omega minus omega naught plus delta omega plus omega naught. So this is the final equations. So from this we need to find the what we call it, this we need to find this we need to find the magnitude. So what is the magnitude for omega naught and negative omega naught? This is pi, this is negative pi. Okay, alright. So that is for example 3. So for the last example in the lecture note is example 4. For our part we will only explain about frequency response related to poles. So the last example, they asked me to plot h omega for hash n equal to 0.5 and un. So this refer to the previous sections. You need to refer it to from the previous sections. What is un? You need to convert to un. How in un is equal to what? And hash and n. So from this is from the previous section. Wait, I don't remember which is, but okay. So from the previous sessions, we will this equation we will convert it to become this equation will become h z 1 over 1 minus 0.5 z negative 1. So as we know that z negative 1 is equal to z negative j omega. So h omega will become 1 over 1 0.5 z negative j omega. So from the equation we know that it has one poles, it has the this is will become negative exponent e negative j omega. So from the equation it said that it has one poles at 0.5 and one poles at 0. So therefore h omega is max when omega is 0. We know from the last sessions I said that h omega is max when omega is equal to 0. So therefore when we substitute it, h omega 1 minus 0.5 e negative j 0, this will be lead to 1 minus ni it will come 0 1 tolak 0 1.05 1.05 something like that. It will become 2. So h omega max is equal to 2. Right. So that's it for the example. So conclusion from what we learned today is for frequency response, frequency response for LTI system is symmetry. It means by that any poles or zeros that exist at positive or negative side, that exists at positive side, it will exist at negative side. So it means that by that z j omega will exist, poles at zeta will have poles at z equal to negative j omega. So more details we explain about poles. Poles equations are h omega a1 over the general equation for poles a1 1 minus e 1 minus e, isn't it? 1 minus r, 1 minus r e j theta, isn't it? Theta o minus omega plus a2 1 minus r e negative j omega, theta plus omega. This is the general equation for poles. Okay, that's right. That's right pula. That's all from us. Thank you for listening.